In this film, we will give information about ELE336 integrated circuit, which is one of the most popular interface integrated circuits of our famous ELE338 microprocessor. This integrated circuit has 40 pins. Noting down the marker on one side of the integrated circuit, the pins are starting from 1 to 20 at one side and from 21 to 40 at the other side. These pins are related to port A and some control signals, ground, port C, port B, and supply voltage, which is untypical. It's not at 40, pin number 40, instead it's number 26, and data pins, reset pins, and other 4 bits of the port A. This integrated circuit is connected to all 3 bus lines of the microprocessor circuitry. The first group of the bus lines is address bus. The second group of bus lines is control bus, and the third group of address microprocessor circuitry is data bus. So all these terminals and the bus lines are connected to suitable pins of the integrated circuit via these blocks. Now the integrated circuit can be operated in 3 modes: mode 0, mode 1, mode 2. In this film only mode 0 will be explained. In mode 0, the microprocessor interacts with the ELE336 integrated circuit such that the control signals are connected to the control bus, and address lines are connected to the A0 and A1 pins, and with suitable electronic circuitry CS, chip select pin, so that whenever a correct address code is given, this chip is selected and functional. In this function, it can input and output from the data bus via control bus signals and create 3 external ports by itself. So microprocessor does not worry about creating different ports from different addresses. Rather, this integrated circuit undertakes this responsibility. So 3 ports. Port A has 8 pins. It can be programmed input or output. Port B has also 8 pins. This port can also be programmed as input and output. Port C contains again 8 bits, but these can be separated into 2 nibbles, each of course containing 4 bits of information, which can be programmed in both ways, input and output. Where do we understand these? We can understand these from the data sheet of this respective integrated circuit. This data sheet can be downloaded freely from internet and published by its producer. Contains information about the chip, the appearance, packaging appearance, internal structure, some functional descriptions, some internal connections, etc., explanations about control signals, their status, etc., address pins, some basic operations, so giving signals to some of the inputs. We can program these 3 ports, etc. Those information are given in this table. Block diagrams, explanation of the pins, mode selection, etc., and definitions of modes. The same figure that I explained in the data sheet. So this figure was borrowed from the catalog information of this integrated circuit, etc., and timing signals, logic conditions, sample modes, and stuff like that. Some basic applications. Absolute maximum ratings, so that you should not exceed these limits, etc. Now let's look at the internal structure of the 8255 integrated circuit. Our circuit has power supplies. They are 5 volts and 0 volts. So we have associated 2 pins to realize power flow or energy flow inside the integrated circuit. Inside, from the outside, read and write control signals are transferred to the integrated circuit, as well as A1, A0. These are the address pins, the least significant 2 bits of the address line from the address bus of the microprocessor circuitry. This integrated circuit has also a reset pin. That reset pin naturally resets when a logic high level is sent to the integrated circuit. And there's a famous pin. This is chip select, which is active low signal. So with this signal and in combination with A0 and A1, this chip is selected and operational in the microprocessor circuitry. Now inside the integrated circuit, of course, we do have lots of latches and other logic circuits. One of the fundamental latches are data bus buffer, which buffers from the internal bus of the integrated circuit to outside world. Here the outside world is the microprocessor circuitry. So from the previous slide, you remember this, okay? The data bus is the outside circuitry. 8 bits data enters from here, okay? So from outside, data is transferred via here. These control pins are here and there, okay? Basically control is from a control bus, and whenever suitable address pins are selected, this logic information again selects this chip to operate or not. So this chip also has an internal bus. It says 8-bit internal data bus, and other control groups and latches, etc. creates other ports like port A, PA7 to PA0, port A, and port B, again 8 bits, and 4 plus 4 bits independently controlled are incorporated in port C. So this chip creates microprocessor controlled 3 ports of 8-bit wide, and 1 port can also be divided as upper and lower nibble of the port C, C lower, C upper. So whenever we see those pairs of letters, we understand that the 4-bit of the lower nibble of the port C and 4-bit of the upper nibble of the port C, respectively. Now the next question is, how do we select this chip 8255 to operate? Okay, here's the basic block of 8255. Okay, these signals are this 8-bit data bus, read, write, reset control signals, and A1, A0, and chip select. Now as you see, these 3 pins are very effective in selecting this integrated circuit, and this chip select is activated by 15 pins. Okay, so there's a logic circuit here. The first one includes, coming from the microprocessor, input output slash memory bar. So whenever this signal is high, this is good news. Then we look at these address pins. Whenever the address pins are suitable, and including these least significant address pins, the chip select signal becomes 0 and these become 1, and this chip is functional. For example, in the circuit it's desired that 8255 should be selected when the address A15 to A0 assume are all 1. Then let's design the corresponding circuitry. So this is 8255, and assume all other control signals are not shown here. We show only A15, A14, A13, A12, A11, and so on. So whenever this is high, when all of them are high, assume we have a huge NAND circuit, then when all high, then this is 0. Okay, so this chip is selected. We need two more pins, which are A1 and A0. Okay, when both of them are high again, this chip is selected. Selecting this chip means high enters and selects the control register inside the 8255 to be functional. Let's come back to our slide example. Here the address lines A15 to A14, A15 is directly connected to the circuitry, so the chip is selected when A15 is high. A14 is again directly connected to the multi-input NAND gate, so this chip is selected when A14 is high. From A13 to A2 we see that they are inverted, so A13 low, A12 low, So if we group these bits, and of course A1 and A0 are also required, for different combinations of these two, we'll select 3 ports and control register of the circuit. So in generally, this is this binary number, and this okay, converted to hexadecimal, and the address bus information 1100 and all zeros and all zeros and 00XX will select 8255 to be operational. Okay, so depending on the situation of A1 and A0, if they are both 0, port A is selected. If it's 01, then port B is selected, and so on. If these are both 1s, then its control register will be selected. So the information in the address bus will select and operate 8255. Now, how do we determine or program the ports, whether they are input or output, is the topic of 8255 control word format. Now there is a register called control register or control word. By changing the corresponding bits in that register, this peripheral adapter 8255 is programmed. This is the summary of the different modes and programming conditions of that word. So this is the 8-bit register from D7 to D0. The control word is transferred to the chip. That transfer is made through these 8 data bus, and the address pins are selected, and these pins A0 and A1 are set to 1, and control register is accessed, and data is written on that register at specific microprocessor timing signal. So whenever this signal is, or this logic information enters into the 8255, the options are as follows. The least significant bit, whenever it's 1, port C, lower part of the port C, CL, is input. Whenever the logical value in that bit is 0, they are programmed as output. D1 bit, or the next least significant bit, whenever it's 1, port B is input. Whenever it's 0, port B is output. Now the next bit, D2 bit, okay, whenever it's 0, 8255 is operating at mode 0. So in that particular film, since we are dealing with mode 0, okay, D2 should be 0 because it's written or given here. D3 bit, which is the 4th bit from the right, selects the upper portion of upper nibble of port C, and when it's 1, these pins are input. When it's 0, these pins are output. Next bit, 5th bit, port A programs port A as input when it's 1, port A as output when it's 0. D5 and D6 pins, which are the second and third most significant bits together, selects again modes 0 0 goes for mode 0, 0 1 for mode 1, and when the D6 bit is 1, regardless of the value at D5, selects mode 2. And the most significant bit, D7, whenever it's 1, it's input output mode, which is the general theme of this tutoring film. It's input output mode, so the pins are programmed as input output mode. This input output mode is explained in detail here, and the other alternative is when it's 0, it's BSR mode. BSR is bit set reset. So in short, the bit set reset mode, you can control the value of each bit at port C to set or reset, to give 0 or 1 to the bits. In this film we are interested in input output mode, so this BSR mode is not explained in detail, rather input output mode is detailed. So mode 0, simple I/O for ports A, B, C, is the main topic of this tutoring film. The other modes are, mode 1 is handshaking mode, or handshaked input output, and mode 2 is bidirectional data bus for port A. So we programmed the 8255 with this approach. Now let's concentrate on the example given on the slides. It's the basic function of the 8255 on the microprocessor circuitry. It's mode 0, simple input and output circuitry. So 8255 circuit is shown here on the left side, left corner, and here A15 is directly connected to chip select, and A1, A0 are connected directly to 8255, and control signals, memory read and memory write pins are connected to read and write. Of course, all of them are active low signals of the 8255 circuitry, and reset pins are connected again. We have 3 ports, port A, port B, and 4 nibbles of port C. They are buffered and LEDs are connected. So whenever these ports zeros are available, LEDs lit because they are connected to positive supply, and port B and lower nibble of the port C are connected to 4 dip switches. They should be programmed as input ports. So basically whenever A15 is 1, chip select signal is 0. Okay, so 8255 is selected. So A15, 14, 13, 12 binary number yields 8 hexadecimal number, which realizes this hexadecimal number to be selected. So whenever, okay, the addresses, the rest of the other signals are all 0, and A1, A0 combination, when they are both 0, port A is selected. When A0 is 1, A1 is 0, then port B is selected. We can write this here. A1 and A0 are all 0. A1 is 0, A0 is 1, A1 is 1, A0 is 0, and A1 and A0 are 1. So 4 different combinations determine the port selected, or more importantly, control register is selected. So in the first moment, control register should be selected, and the control word here, D7 is 1, D6 is 0, D5 is 0, D4 is 0, D3, 2, 1, 1. Okay, let's solve or try to decode this information. D0 and D1, 1, 1 means first port CL is input, the lower nibble is input. Okay, so this input is decoded in here. Input being an input is programmed by this bit. All port B should be input, programmed to be input. All port B pins are, this is input. Why? By using these switches, data is transferred into 8255 and then to the microprocessor. So D20 means port B in mode 0, and all these are gathered over here. D0 information, input, D1 information, D2 mode selection of group B pins. D30 assigns port C upper as output. Port C upper output is related to this. Look, all of them are output. LEDs are connected. When suitable data 0 is given, corresponding LED blinks. D40 programs port A as output. Port A, again output, is programmed to be output by setting this pin to 0, and D6 and D5 00 information programs port A in mode 0, which is this, and group A 00 mode 0 is selected, and this information is gathered from the catalog information of 8255. Now, as a result, control word is 83 hex. Now let's try to design the program. This number 83 hexadecimal is stored in lower byte of register A. Then this hexadecimal number 8003 is stored at register BX. Then the value stored in AL, which is this value, is sent to the address 8003. Address at 8003 is the control address. So whenever it's sent, this chip is selected and control register is active, and this value 83 is stored into that control register. By storing this control register, this value into the control register, this is programmed such that port A is all output, upper nibble of the port C is output, port B is input, lower nibble of the port C is input again. So there's a circuitry which realizes input and output bidirectional programming of the 8255. So microprocessor utilizes these 3 ports accordingly, and then so these 3 lines programs 8255. Next line, another value is stored at BX. Okay, this value is related to the port C. So whenever this value is sent to the address register, port C is selected. So the address, okay, at this address, the data pointed at this address is stored into AL. So whatever the data at port C is stored into AL. Look, at this address, port C has 8 bits. Only 4 bits is useful for us. These 4 bits are the lower nibble. So we mask the higher nibble by AND operation. We mask because AND operation makes the higher 4 nibbles 0 and lower nibble information is transferred to AL. So in AL, definitely we do have 4 zeros at the most significant nibble, and whatever the information at port C lower. Then from port C lower, we read from port C. Then we decrement BX twice. Decrementing means BX is from 8002 to 8001, then 8001 to 8000. Port A is selected. After port A is selected, the information stored in AL, which had been read from port C lower nibble, is sent to the address where BX register holds it. So display at port A is realized. Read from port CL, read, then display at port A. So these from the 8 bits, 8 LEDs, the most significant 4 LEDs do not turn on, and least significant 4 bits turn on or off according to the dip switch information.